So the topic today is about how cloud changes everything for disaster recovery, business continuance, and more broadly, business resilience. And as I was putting together the presentation, I was thinking about the age of cloud. And what dawned on me is actually those of us who are old enough to remember the 60s, I was very young then, but I do remember them. Also remember that song, This is the Dawning of the Age of Aquarius. What's actually interesting is apparently the age of Aquarius is this year, and the dawning was happening way back 50 years ago or whatever the heck it was. So I thought, is the age of cloud something like the age of Aquarius? And actually, if you look at astrology, supposedly it is. So you can kind of think of cloud as being the technology instantiation of the age of Aquarius. And I've given you all something to go Google to find out what all this is about. But with that what we can't deny is the fact that cloud changes everything. So let's talk a little bit about the whole notion of cloud, how people are moving to the cloud, and business resilience. So first of all, and by the way, I'm deliberately skipping all the about Nemertes, about myself, but the very short answer here for those who aren't familiar with us is, as Alex said, we're an 18-year-old research advisory company, which means we are founded by IT and technology practitioners, and we base our insights on continuously conducted research that we do ourselves, self-sponsored, to find out what practices align with success. And you'll see a lot more about that in the upcoming slides. So one of the things we're constantly asking ourselves, what are people actually doing? To what extent are people really moving to cloud, for example? And what distinguishes the most successful cloud users from less successful cloud users? And you're going to see a particular slice of that research in the next couple of slides. So the first finding here is actually 2019 was the year that we tipped over and the majority of workloads were in cloud. As of 2020, what we found was that 23% of workloads were in software as a service, 17% were in infrastructure as a service, and 14% were in PaaS, platform as a service. If you add all that up, what that tells you is just under half the total IT workload is left in the data center. For the vast majority of financial services firms, exclusive of some of the more digital native organizations or dinos, but more quote unquote legacy, older, more established financial services firms have and will continue to have a hybrid environment for years to come. But that said, a lot of the data, a lot of the workloads are now living outside the data center. So essentially what you're looking at is an architecture that's going to be your go-forward architecture for the next 20 years. Some percentage of your workloads are going to be executing in SaaS, some percentage of your workloads are going to be executing in IaaS, and some percentage are going to be executing in PaaS. You're going to be getting there over a combined network of direct internet access, increasingly using things like SD-WAN, as well as a shrinking proportion of your traffic traveling across the corporate WAN. So if that looks a little bit like a spaghetti chart, that's because it kind of is. There's a fair amount of complexity here. So how do we take all this complexity and say, what makes business resilience and cloud successful? So here's our success definition. And let me stop for a second as you're reading this. What we typically do in any research study is say, how do we define success? And we recognize that there are giant institutions and organizations and frameworks and whatnot that have multiple KPIs and dashboards and all that to sort of work at a multifaceted definition of success. What we try to do is cut through all that, simplify it, and pick the single metric, if we can get it, that says this best epitomizes success. Again, it's a blunt hammer, it's a blunt force move, but at least it allows us to say at a first cut, this is success. And so what we came up with was the mean time to identify and restore services, cloud-based services, which we dub the mean time to return to normal, MTTN. So in other words, something happens, you have to figure out what happened and what it affected, fix it, and now the services is returned to normal. You may be saying to yourselves, well, Johna, that makes no sense. we look at cloud success as reduction in cost, as agility to roll out new services. Those are all good metrics, and separately we have looked at those as well. But in the broader context that we're dealing with today, what we really want to be looking at is how quickly you can get back to normal operations in the cloud. And what I'm going to share with you is that it's actually surprising, the distinction between the people who do it successfully and the people who do not. So first, this is our benchmark group. By the way, many of you will be asking, and I didn't include a slide on the, actually I did include a slide that talks about our studies in the abstract, but typically we have about 400 organizations across 24 verticals in 12 countries, more or less, give or take a few, for the research studies that we do. So the MTTI, mean total time to identify, is about 19 hours on average. So it's about a day to figure out what went wrong on average. Now keep in mind, this is the average. Mean total time to resolve is almost 12 hours. So it takes longer to figure out what happened than it does to fix it. But actually, both of them are taking way too long because, as you can imagine, if that's a business critical function that is down for 18.8 plus 11.6 equals 30.4 hours, that's way too long. And you're going to hear about it from the higher ups. So, question. Success group versus average. The success group can do all of the above in 29 minutes. Now, you may be asking yourselves, what is the success group? Like, how do you define the success group? And typically we do it by percentile. So we look at the data and we say, is there a ball of people who cluster around success of this metric? And where does that ball, it's kind of a Gaussian curve, where does that naturally cut off? And typically that's around the 80th or 85th percentile. I believe we used 85th percentile in this study. What's interesting is not the fact that we obviously cherry-picked, so to speak, the top 15% successful, but that the difference is so dramatic. 30 minutes to 30 hours. That's a 60 times improvement. So hopefully what you're going to be taking away from today's sessions, not just from this PowerPoint presentation, which is nice, but also from the interactive discussion on the panel session with the practitioners who are in that success group, is what practices align with success and what technologies align with success, and what can you do to improve that success. I will highlight something. MTTI, mean total time to identify, is begging for analytics, and that's an area we're going to talk about a lot on the panel session. Mean total time to resolve is begging for automation, because obviously analytics helps you figure stuff out faster. Automation helps you do it faster. I realize it sounds like I'm vastly oversimplifying things, but I'm really not. If, a business executive wakes a technologist up out of a cold sleep and says, what's the value of all these expensive analytics you just bought? The answer is we can figure stuff out faster. And then, of course, the next question is what stuff and how much faster? And similarly, why are we investing so much in robotic process automation? So that we can do stuff faster. What stuff and how much? Okay, that's the details. But if you think in terms of those two chunks as business value, it helps a lot to really justify your investments of time, energy, and dollars in those two areas. So, success group is nearly 100 times faster at restoring services. Also, they are almost 30% faster at figuring out what went wrong by percentage. So in other words, as you can see, the ratio of the blue to the yellow, the success group is figuring out faster as well as acting faster, but there's an added kicker to that figuring it out, because it turns out that with cloud, root cause analysis, with cloud and DevOps, which are usually intertwined, root cause analysis can be an absolute nightmare. So being able to do all that quickly is a huge advantage of adopting the right sorts of things for, for your cloud environment. So what sorts of things are we talking about? So this is a little bit of an eye chart, so I'll let everybody kind of get used to it a bit, and let me tell you how to read it. Obviously, down the left, there are different technologies. Application platform as a service, that's actually having those application platforms that help you glue together, along with integration platform as a service, glue together various cloud services. Communications paths, same thing, except for communication services. Serverless computing, pretty straightforward. Containers and container orchestration, very straightforward. Hyper-converged infrastructure, you'll be putting that in place in your data center. Software-defined networking, again, a primarily data center technology. Cloud management platform is exactly what it sounds like. It's a platform that allows you to manage both your public cloud and your private cloud instantiations. Cloud service broker is exactly what it sounds like. It's locate which cloud service you want to be using for a particular workload. Cloud configuration automation, exactly what it sounds like. How do you automate the configuration of your instantiation in the cloud? Cloud cost management is typically a solution that goes with all that ties into the cloud service broker and decides. It's essentially policy-based workload routing, if you want to use those words. Cloud access security broker is what it sounds like, typically used for software as a service to automate, integrate, and streamline user access to SaaS. And cloud-based identity and access management, something like Ping and Okta, which allows you to have cloud-based single sign-on, is another good way to look at it. So, okay, basic understanding of what you've got from a technology perspective. The adoption is, these are the folks on the left under adoption is what percentage of each group has adopted this? So we split the total group that we studied. Again, that's that 400 companies approximately. The 80% that weren't, or 80 to 85% that weren't in the success group, what was their adoption rate? The remaining percent that were in the percent group, in the success group, what was their adoption rate? And then we looked for differences. So one thing we saw was that actually, surprisingly, the success group was less likely to have adopted container orchestration, which is kind of interesting. We're not saying container orchestration is a bad thing. We're just saying that that's actually, and adoption has aligned with, less adoption has aligned with success. They are more likely to have adopted software-defined networking, cloud service broker, and cloud configuration automation. So that's kind of interesting. Then if you looked at the MTTN, we took another way of looking at that data and said, if you do adopt it, what is your percent improvement in MTTN? How much smaller did your MTTN get, or how much better? So if of the folks who had adopted it, did your MTTN improve by 20%? Did it improve by 18% with APAS, CPAS? Did it improve by, for example, SDN, CMP, and CSB? All you see an improvement of anywhere from 40 to 100%. And CASB also helps you improve with 32%. Again, you're seeing some challenges with container orchestration. My best guess as to why that is container orchestration is somewhat complex. For those of you who are in the process of putting that in place, it adds to some of the complexity because you actually have to build in security and management around container orchestration as another element in your cloud. So it's not a bad thing. In fact, I do encourage people to deploy container orchestration, but do it with open eyes. Moving to the practices that align with a successful cloud organization. Now you know how to read it. We can go a little bit faster. We asked people what the state of automation was for various coding practices. And we also asked, what are they doing? Remember I said DevOps and DevOps and cloud are tightly coupled. What we found was that ad hoc automation for change management improved your MTTN. So did ad hoc automation for your coding standards. It's not so much for code management or for a standard tool set. And again, probably the DevOps practice that most will bring you benefit are scrums. This actually makes logical sense to me. It kind of tells me that if I have to start somewhere, I want to make sure that I'm automating my change management. And again, automation helps you with that second success metric that helps you respond. I automate my coding standards and I try to adopt scrums ahead of sprints or code security analytics or other practices. And by the way, you may be asking the question, there are dozens and dozens of other practices you could have run against the success metric. We asked some, not all. Some other ones, and this one I think is actually very, very interesting, is that having a cloud security architecture is kind of a meh here. Most people have it. It doesn't really correlate with success. I kind of view that as a table stakes data point. It means that you should have a cloud security architecture, but it's not necessarily at this point going to improve your success. Having a workload placement process and a cloud onboarding process, those two are actually significantly likely to improve your success, again, by the measure of success being narrowly defined as how quickly you can return to normal. What about people? If you have to build out your cloud team, one of the things you really want to invest in is a cloud acquisition specialist, as you can see from the things that have the green boxes around it. What is a cloud acquisition specialist and what does he or she do? It's the person that works with procurement to procure the services and make sure that the services have the right T's and C's to operate effectively in your broader service delivery environment. The reason this person matters is you as an IT organization can only deliver cloud-based services effectively to the degree that they are delivered effectively to you. It's the job of the cloud acquisition specialist to make sure that they can deliver, that the cloud provider is delivering what you need to bundle into the services that you are delivering. Similarly, cloud integration specialist, that one pops out with a big 50% improvement. That's the person whose job it is to, guess what? Integrate all the different cloud services that you've got so that your cloud services are actually talking to one another. Lots of different ways to do that. That's where APAS and IPAS come in. Very interesting area to be exploring in 2021. And finally, the cloud solution specialist. This is the person who bundles together the various cloud services, cloud offerings, and delivers a solution to your internal users. So is it going to be a little bit of, something built on AWS integrated in with your Salesforce or PeopleSoft? Is it, then added to a custom application that's actually rolled out in your data center? It's the cloud solution specialist who glues that all together and delivers that to your end users. So kind of the takeaway from this, before we hop from this particular slide and kind of wrap up, is that the focus areas with cloud, you really will have a shift in focus. Yes, the technology matters, but it's not so much about the technology behind the cloud as it is the technology, the interface between you and the cloud providers, and the integration of the cloud services, and then the delivery of those services to your customer base. Last but not least, one of the things people always ask is, well, those successful people, they're probably able to respond a lot faster because they don't actually have very many events. Not true. It turns out more successful organizations have six times as many service incidents annually, even though they're really not making, much. They're only making about as many changes in a year as all other. This really comes down to being able to recover faster from any incidents that happen, coming down to better knowledge of what's where, better knowledge of how things are interconnected, and better containment of, and you'll hear a lot of talk about this, the impact or the blast radius. So kind of summing this all up, I am sparing you the indignity of a slide that says summing this all up. Bottom line is, if you want to measure your effectiveness for business resilience in cloud, start thinking of mean total time to return to normal operations. And if you wish to prioritize a set of technologies and practices that you want to adopt in order to get to that MTTN, a good thing to do is start with some of the ones that we have here. And before anyone asks, yes, the deck will be available as a PDF to anyone who wants to look at it. My colleague, John Burke, who is our cloud leader here, is more than happy to work with folks to improve this. The only thing that we ask is that you not promote, use the deck or publish it externally. You're welcome to use it internally in your organizations and benchmark yourselves against the numbers, or benchmark your solution against those numbers and see if there's a way you can tie your solution to reducing those numbers. So with that, as I said earlier, basically we're looking, this is research we conducted in late 2019 and throughout 2020, They comprise both interviews and surveys, meaning we actually talk to people. This is not just click a box and get an Amazon gift certificate. And typically we've got about 400 companies, 12 countries, and 24 verticals. So it's a fairly broad base. I won't say it's absolutely comprehensive, but definitely pretty solid. And with that, I think we are ready to get on to the panel. So I'm going to stop sharing. Thank you guys much. I am seeing that there's lots of feedback and comments. Keep in mind that as you're asking questions as we jump into the panel, we can certainly answer questions that we talked about on the presentation. So with that, Alec, I think we are ready to bring our panel up, as I believe.
Yep, I think Teresa is working on this. Give her a second.
We're lining our people. I know I was a very, very bad presenter. I came in roughly 45 seconds under what I was supposed to be doing. So I pride myself on being able to do it to the second. And
yeah, not so easy.
Yeah. And we'll be having people do their introductions. I'm going to ask everyone to do their own introductions so that you'll hear from the horse's mouth, so to speak. And I believe, are we missing anyone? I think we are good to go. So I'm going to go ahead and, because of the way this plays on my screen, Allison, you have the advantage of going first. If you want to just give us all, a quick summary of yourself and your extremely impressive background, that would be outstanding.
Sure. So Allison Gorman, Nachtigal from Morgan Stanley. I've been a Morgan Stanley lifer, which I guess at risk of revealing my age, I've come up on 30 years there. Long journey, many roles. And I think the ones that are most pertinent to today's topic and the area that I'm covering off are kind of two. I've spent a large portion of my career in enterprise computing, all the systems and applications and platforms that we are now looking to transform as we go to public cloud. So essentially taking about 15 years worth of build and putting a lot of my old stuff out of business, which is kind of a funny journey. About somewhere like 2014, I actually paused my role in infrastructure, and I had a great opportunity off the back of not good news to the financial services industry, which was that we were at risk of serious data breaches and data destruction, and that was something that the Fed felt we weren't totally ready for. And so we locked arms and actually came together, and I had the wonderful opportunity of forming an enterprise security platforms team that was intended to actually marry those security guys that no one could quite figure out what they were doing back to those infrastructure people who thought that security stuff was probably interesting. And I spent a little over 3 years doing that. And that was essentially my training ground as I returned back into core infrastructure and took over over the course of a couple of years both our broader cloud initiatives, which include on-prem and public, but very directed towards leading our public cloud transformation. I know we have a DR and resiliency topic today. I'll add a brief perspective. Morgan Stanley really can't take outages, and we build the Noah's Ark of infrastructure. Everything is high availability and BCP. In many ways, I don't even talk about DR because by the time we recover from DR, we're basically working ourselves out of business. And we do have plans if it ever came to that, which it won't. But as a result, we plan for the unplannable. And with the pandemic, that actually has served us well because no one really would have played this scenario out in a tabletop. But one thing I will say, public cloud is a great opportunity as long as you transform your applications, and we'll talk more about that theme, to just get a whole new opportunity for resiliency. So I'm looking forward to today to dig into that topic.
Great. Thank you, Allison. And Zach, take it away.
Great. Thank you, Johna, and thank you for having me here. My name is Zach Murad. I'm the Chief Information Technology Officer for S&P Global CRISIL. I've been with S&P for a few years. Before that, I've been around Wall Street for quite some time. Majority of my professional career actually has been with financial firms, anywhere from Goldman to JP Morgan to BNY Mellon to Lehman Brothers and Barclays. That essentially sums up my career. It's good to be able to say that in 30 seconds or less. So as part of that, I've done a number of roles. I've been in infrastructure. I've done, a lot of hands-on type of work, anywhere from development to infrastructure engineering, built up the cloud capability, which is really the private cloud capability, with a really good team at Barclays. We did a lot of interesting work at Lehman, where a lot of the automation work that is part of cloud, something that we were building 10, 15 years ago. I think Morgan Stanley, Goldman Sachs, we were doing. A lot of us have been doing that, and a lot of peers that I have, good relationships with folks around each one of these firms. A lot of us went through disaster quite often, right? Unfortunately, right? So I think of 9/11 as one such, which was completely unplanned. And those of us that were around, I was at Lehman at the time, do remember, when that happens, there's the shock of it and then unbelievable event. At the same time, how we recover from it for the next 2, 3, 4, 5 days is a learning experience that all of us carry. And when I think of disaster, I think of what would happen if something like that did happen, right? And COVID is another one. And disasters, when they happen, they're really not the same. Like S&P got hit, we had our data center downtown. So when Sandy hit, then we were impacted, right? So our data center is there, now you exit. So everything comes in different flavors, trying to learn from it. I'm a technologist at heart, I'm an engineer. I get into a lot of details, it's a lot of fun stuff. Moving into cloud has been awesome. We migrated the ratings division 100%, 175 applications, and Johna, we spoke about it before, right? Within 8 months, that was an experience. And cloud is very different, and great to have to talk about this. Would love to share ideas. I think it's an exciting topic.
And we're going to come exactly to how different. But before I do that, Chris, if you don't mind unmuting yourself, and hopefully your internet is going to work. Chris and I were having a little discussion earlier this morning.
Yesterday afternoon was a bad day for internet. Chris Colotti, I currently work for Cohesity. I'm a field CTO with the company. Prior to coming here, I was actually, my career spans from system administrator to field CTO today. So when I was a customer a long time ago, I was much like Zach. I was, designing for disasters. It was back before cloud was even an option for a lot of folks. We were still trying to figure out how to fail over storage networks. I spent a lot of time at VMware, and that's where I did most of my BCDR work when SRM became a product, and then as that grew, and then I spent a lot of time in the cloud space at VMware when they released their cloud management product to be to their partners and to build out cloud providers. So I actually did a couple of cloud provider designs, and this topic was always top of mind. And I think we're going to get into that later, but the provider has a different view of resiliency than the customer. So, and I think that's part of one of our topics today. So I won't let that out of the bag yet. But it's since moving to Cohesity, I mean, we primarily do recovery solutions. So it was an interesting fit for me to come over here. But like Zach, also very much technologist. I tinker with more stuff outside of work, technology wise, and I think I do it during work. So.
Great. Thanks, Chris. Paul?
Hi, I'm Paul Curtis. I'm the Principal Solutions Architect for Weaveworks. My background started with writing financial applications. Okay, so I worked writing code for Wall Street in contractor or our companies building out applications for them, and it started there. But my background more recently has been both in big data and in building out Kubernetes on top of machine learning and large data sets. So coming to this discussion, I bring all that background is like, how do you do that, especially when you get to public cloud? And the second thing is Weaveworks as a company is all about Kubernetes and containerization in all public clouds and data centers and everywhere else. So we bring a methodology to it to allow you to rebuild and rehydrate or restructure your containerized applications very, very quickly. So the things that the cloud brings you as positives, like being able to spin up infrastructure fairly quickly, we extend that out and say, not only do you do that, but you spin up the applications and the data sets as well. So as a disaster recovery solution. It's more about, do I need to have a true hot DR? Can I spin up some things and not others? Do they have to be there? How do I migrate the data? And how fast can I do it? And so our company is very involved with financial companies figuring out and architecting how to do that with Kubernetes.
Great. Thanks, Paul. Rich?
Hi, thank you. Hello, everybody. My name's Rich Cooper. I'm the principal of Financial Services Division at Fusion Risk Management. And primarily my role is to advise large financial service firms and the financial market infrastructure on resilience postures broadly. And I have really gone back to the stone ages of disaster recovery, because my first real entree into this was working for a company that was ultimately part of Iron Mountain and a division selling backup tape. So we literally had to be loading the tapes and putting information in and figuring out, did we even have the tape drive that these tapes would go on? And then we fast forward to today, where resilience is all about trying to anticipate and prepare. So watching that Sandy storm come in, watching COVID impact our vendor community in Southeast Asia first, potentially, before we get into it hitting the domestic markets and our operations. So really through the whole gambit. My expertise is not on the technical aspect, but the practical aspects today of, being resilient and leveraging technology for the right side of the firm. And I'm really looking forward to this conversation. Thank you.
Yeah, Rich is our risk guy. And Robert, last but far from least.
All right, I'm Robert G. I'm Director of Cloud Infrastructure at Castle Integration, which is a company focused on financial institutions. It's a service providing company to them. So I've held over the years, I've been here 18 years, and I've held over the years many different roles at Castle. But one of the first roles and the most fulfilling was design our first disaster recovery product for our clients. And the cool thing about that is 18 years later, I still own that group. So we've designed solutions and executed them for hundreds of clients. Like everyone else on the call, right? We've been through the hurricanes, the building issues, 9/11, all those fun things. And it's passion, and disaster recovery is fun. I guess the disaster is not fun, but the topic and making it work is fun.
Well, I have to say, and that was a great wrap up, Robert. I think a better way to look at this panel is we've all been involved in disaster recovery and business resilience for a couple of decades, and we're still here, and we're willing to talk about it, and we think it's kind of fun. So in some sense, that's a self-selected group already. Zach, I'm going to go ahead and direct the first question to you, but I'll go through the entire group. You mentioned the whole notion of how things have changed. So if you want to kind of summarize, boil up a couple bullet points, verbal bullet points, so to speak, on how disaster recovery, business continuance, and resilience have changed with the advent of the cloud era, that would be great.
Yeah, I think a lot of us are moving to the cloud because it gives us scalability, agility, and all of those nice things, because we say we need to move very quickly. At the same time, when we're inside a data center, we can look and feel the hardware is within our control. And essentially what we're doing is we are relegating a lot of that control over to the cloud provider. And the cloud providers are extremely sophisticated. There are a lot of moving parts under the covers, right? So without an understanding of what those moving parts are, the number of failure points that can happen suddenly starts to increase very, very drastically. So our ability to understand what those failure points requires a lot of maturity, and we can get a lot more resiliency out of the cloud if we know that. At the same time, the level of sophistication that we needed to have when we had a simple architecture within our data center, right? We had storage devices, we understood, we had servers, we understood, and VMware helped simplify some of that for us as well. You kind of knew the devil, right? You understood it. However, in the cloud, it is absolutely new. And then we have layers upon layers upon layers of abstraction. And each one of those layers can start to add additional failure points. And the way that you manage the configurations, each one of them has a configuration. And the configuration can change, which means that you think of it as entropy, right? It continues to increase within the environment. So ability to manage our configurations, ability to manage how we understand the cloud and manage it and get the best out of it with the lens of things will fail. And how do we recover from that failure? And more importantly, how do we automate those failures is really important. And that, I think, is a big difference. You could get away with not automating on-prem, but as your environment is so much larger and so much more complicated, being able to do infrastructure as code becomes extremely critical.
So I've got 5 main differences, and Paul, just to let you know, you'll be up next. But I've got number of failure points increases, the novelty of the environment has increased, the number of layers of abstraction has increased, our ability to manage has dropped, and the need for automation has increased. So that's a lot to have changed. Paul, what would you add to that?
So you add another abstraction layer on top of that when you put containers and container scheduling in there. So if you add Kubernetes, all of a sudden you have no choice but to build out all of your infrastructure, whether it be the low-level infrastructure that Zach's talking about, but also the application infrastructure as well. Kubernetes gives you a nice way to schedule out and try to build applications that are opaque to the underlying environment. And the kind of tooling that you use to do that, infrastructure as code and GitOps, which is the other methodology that the Kubernetes community is using, is very good. But one of the things that makes it vastly different is in your own data center, you know what's underneath there. You know what's below the network layer, or you know what's below the Kubernetes CNI. In the cloud, you don't. And you have to trust them, trust those providers to give you what you need in order to do it. The other side of that is the cloud gives you a very distinct advantage in that I can go from 0 to up and running application full Kubernetes cluster, excluding data for a second, but application and network stack in about 15 minutes. So these are the trade-offs that you're making here. You're trading off knowledge and risk in layers that you don't control, like networking, for example, versus the ability to have a mean time to recovery that might be measured in 20, 30 minutes. But yes, there's a risk underneath there that you have to assess. And as Zach will tell you later on, there's also a cost associated with reducing that risk in the cloud providers.
So
but in
Paul,
either case, you do get that speed.
Sorry, Paul, I was listening to the cadence of your voice there and I jumped in. So essentially, I would take your differences as the necessity for using containers and container scheduling, which I would agree with. The lack of knowledge of underlying infrastructure in the cloud environment, but the flip side is the ability to actually do a full restore sans data, a full Kubernetes cluster restore in 15 minutes or less, which is actually a power you didn't have. And then you talked about risk. So I'd like to bring in our resident risk expert, Rich. I'd like to ask the question slightly differently of you, Rich. How do you see the risks shifting when you're looking at business continuance, disaster recovery, and the moving to the cloud? So how is it different? How are the risks different in a cloud world?
Well, quite frankly, you're not transferring the risk. That's the first thing. That's the mistake. You're not just saying all of a sudden hey, that's someone else's problem. You are assuming the risk. The regulator's expectation is that you're assuming those risks. And the fact is, you do have a more complicated work because these vendors could have subcontractors that both Zach and Paul touched on there. And for me, the risk is versus the impact and the severity on your firm. So as Paul alluded to there, anything can be resilient, anything can be redundant. You can have redundant people sitting on the other side of the world, hovering over keyboards, ready to kick in just in case something happens. That's an extreme case of resiliency, but you have to find that cost mechanism to where it makes sense to take your risk appetite. So for me, it's about risk appetite. You're not going to have those people completely redundant. You're not going to have every single part of your whole firm redundant. You've got to look across this and say, does this make financial sense to be resilient at that stage? So,
and I would really like to highlight that notion of you're not transferring the risk. It's one key takeaway, but I think it's incredibly important. It's a thing that doesn't change when you move to cloud, and yet many people think it does. Well, hopefully you don't, but
hopefully not.
Right. So Chris, what about you? What are the changes in the things that have to change for business continuance, disaster recovery, and BCP with the move to cloud?
Yeah. So one of the things I've always talked about people know me in my company as the process guy. And I think process is a huge part that changes drastically. It's one thing to know what your process was when you had to go get tapes back from Iron Mountain, which we all giggled when Rich said that.
Yeah, I know we
We're
did.
getting them back and forth, but you had a very easy process, right? You put in the order, you get them back, you reload from tape. We moved to on-prem and we had to redefine those processes. And I think what I've found is people are struggling with it more. And it's not just the process, it's the personnel, the knowledge level of the personnel doing it has to shift. And there's a lot of people who don't like change. Some people welcome it, some people don't. And that up leveling of their knowledge base of all of these things and I took some of the notes that you did of the failure points and the abstraction and what they have control of and what they don't have control of. And siloing those off and saying, well, this is the side of stuff we can't even worry about because we can't touch it. We don't own it. It doesn't affect our process. But this is the stuff that does. And it's still a very large bucket. It's actually a pretty big bucket compared to what it used to be.
So, Chris, I want to add an add-on question to that because I just finished an article for Tech Target where I was talking about IT cost optimization. And one of the recommendations that I made was revisit your processes on a regular basis and ask the 5 whys. Why are we doing this anyway? Because 99 times out of 100, most processes are based on not only obsolete technology, but like obsolete by several generations back. So, for example, in the example I gave was like you might be requiring a signature-based approval that migrated from the era of fax to the era of PDF signed email exchanges of PDFs to the era of DocuSign, and yet the entire process itself could be obsoleted by an auditable workflow process where you just click a box. So given that, are there any processes that you could point to just quickly that would be like totally obsolete once you move to cloud, and yet most companies happen to have them?
Oh man, off the top of my head, that's one I'd have to think about. But I think your example of signatures is a big one. I mean, we run into that even in the change management processes today, right? And people actually are starting to struggle with, is a DR event a change management event, or is it an emergency and it just has to get done? There's the approvals, whether it's signatures or approvals in any way, but any manual processes, to Paul's point, anything that's still listed in the run book as a manual process that could be automated, and it may not have been able to be automated even 6 months ago or 2 years ago, but now can be. If you haven't revisited that within a recent time frame, it becomes very dated, and you have to try to figure out all the pieces that you can automate within the process. There's always going to be some manual stuff,
right?
But do you have the personnel in the right places? Rich touched on this, but do you have redundant people in areas that are not within the blast radius and of the event, or that can get to a different console to even do the manual process that's in place?
Yeah. So basically, your big thing that's changed is all the processes. We can't tell you which ones until you examine them. But while you're examining those processes, look for areas that are manual and ask yourself if they can now be automated because cloud is kind of the way to look at it.
Yeah.
Okay, cool. And kind of wrapping up with the last couple. Robert, what about you? What are your thoughts as to what's changed? You're on mute. You're on mute, my friend. There we go.
I think a lot of things have changed here, and one of the things is how do we ask questions to those cloud providers? What are the questions we should ask to understand their infrastructure? As you alluded to earlier, and a couple of the other people here, it's a very good point. As IT professionals, we're responsible for the outcome, regardless of who's running the infrastructure. And so understanding what's under it, how it's going to fail, and et cetera, is really important. Providers put out a lot of 9s on their SLAs and things. And let's understand what an SLA is, right? It's a financial return if they have a problem. It's not a guarantee of uptime. It's a target for them to hit. And your business, if they miss their target, is still the one that pays. So I think you should request historical data against how they perform, with their SLAs. You should ask about how it's designed, especially if it's an application written on top of a cloud provider or a cloud native application. Does it use multiple regions? Does it use multiple cloud providers? How does the failover happen itself? Is it an automatic? Is it a manual failover? All the things that you would ask within your company.
So And I'll interrupt because I know you're going to speak to this a bit later, but essentially what you're saying is what really has changed is the need for a playbook of questions to ask the providers that didn't exist before when the providers didn't exist before.
Yeah, exactly. The things you use to ask internally.
Excellent. Allison, last but not least, what you've lived through this for a while. What has changed with the move to cloud?
Enough that I would say we are undergoing, a material transformation in the way that we handle our cloud adoption, particularly at the application level. I mean, we've all mentioned tapes a couple times, and it just brought to mind this story. We have an air gap requirement as part of regulatory needs. So imagine you get hit with ransomware, your backups need to be air gapped. We've all been writing tapes forever. By definition, if ransomware hits, they're not going to get onto that tape material. And so when we were looking at, figuring out, well, how do you meet that requirement in the cloud? Someone on my team said, you actually can cut tapes. And I looked at him with a death stare. I was like, no, not doing that. And that philosophy is the one that we're trying to take as we approach our migrations. The two big things to me, and there's many, but what stand out is application renovation and operational transformation. Your applications cannot trust the provider. I think Paul earlier said trust the providers, and I understand his point, but our applications cannot trust that infrastructure to be there. They need to be built in a fully defensive way, knowing that that infrastructure could disappear, and they need to be able to recover. As part of that, and one of the big reasons for that is because there's just no way of knowing what's under the covers, and this was mentioned earlier. What are you getting from that cloud provider? What's the blast radius of one of their outages? And we could talk about that some more, but just really understanding what's going on underneath that application is so difficult, all the nested dependencies, that those apps just have to be built to survive. And with that, your operational capabilities has to transform. So a big part of our security posture is least privilege. Anybody who touches anything, any production ID or human identity we give needs to really be minimized in what it can touch, because that helps our cyber resiliency, which is a huge part of the equation. And so off the back of that, your applications are highly segmented to people who could touch them. And that all-powerful DBA you have on-prem simply can't exist. And that means a lot of operational processes shift left. And so that adoption of DevOps that was mentioned earlier is also just a critical ingredient if you're going to go out onto the cloud and be able to stand up against and meet the resiliency requirements you have.
So the God DBA goes away with the operational capabilities, and that least privileged is key. And the whole applications can't trust infrastructure. I love that, because I actually, just before this whole session, got off a call with the CISO of a very large organization who threw out as a design criterion for a network, hey, how does the company continue to operate if internet blows up? It's like, well, that could be fun given the, move to direct internet access. And it's a legit question for them. Okay, Zach, you have referred a couple times to the proliferation of an increased complexity of control points. I'd love for you to drill down into that and give us a couple of detailed examples of what you're talking about, because I think we all kind of nod our heads and go, yeah, that makes sense. But if you could run through some concrete examples, I think that would help to crystallize the idea in everyone's minds.
Absolutely. But before I do that, I used to be a DB, Allison, and I never felt like a god. And I guess the trajectory for all DB is to become CTO, CIO, which is not a bad gig to go forward with. So it's really awesome. And I agree with you. I think the application stack is completely changing, right? And the complexity that you have to deal with needs to be abstracted away at the application layer, which is really where Kubernetes comes in, because it essentially is almost like an operating system. We've started to go through a lot of move towards containerization, and Johna, earlier you had mentioned that you don't see as much move, but I think that is definitely a shift towards containerization. We've also done a lot of shifts towards a serverless architecture, right? So if you drill into something like a Kubernetes, and you're now running containers, and containers can live or die very quickly, and maybe you're breaking your monolith application down into microservices, you can have a really gnarly issue at Istio if you're using Istio to manage your service mesh. and being able to dig your way out of it can be an issue. And that issue could itself be because the core network layer that is being provided by the cloud provider is really where the issue is. So you need to have the engineering capability to be able to drill all the way down. In particular, you have an application that is sending traffic, and you don't have the observability built in, right? So for example, we've started to integrate a lot of open telemetry as part of observability, and then just make that as a baked in process so that I can have end-to-end visibility when you have an end user that is doing something. So you have end user performance management from the front end. Maybe you're using injection or something else on the front end, but be able to trace it all the way down to your microservices layer through all of the different integration layer, and be able to consolidate all your logs in a single place, right? Whether you're using the Elk stack or whatever else you're doing, and be able to visualize it. That's really, really important. Now, that doesn't come easy, right? A lot of that requires investment. The second piece of it is, if you're going to be sitting there thinking about, I have to, invoke my disaster recovery, there's a cost associated with all of this, right? So you have to be able to come up with a business case to be able to say that, there's a trade-off, right? This is how much risk am I taking? And then now if I'm going to invoke my disaster recovery, however, it doesn't work. So we spent a lot of time saying, we need to take the risk out of this environment so that we're going to wipe out the entire environment, for example, once a month, and rebuild everything from scratch, so that if anybody went in and did something manually, guess what? It gets wiped out. So we were having conversations. It was an engineering level conversation with some of the VMware guys that do Knative code, they're Knative, open source engineers. And they're committing code there, the code committers. And one of the things that we spoke about was, we're wiping down our entire Kubernetes cluster and rebuilding it. And that was a little bit of a weird idea, because why would you really wipe out, hundreds of applications? But then, what it did is put in a lot of discipline for us, because that means that we don't allow people to go in and make something that is a manual change. Everything goes through GitOps. Everything goes through that pipeline. So some of those practices really come in, so that when we invoke it and we rebuild that cluster on the DRM failover, we're pretty well guaranteed that it's going to come back up and it's going to run. So there is a fair bit of complexity, but in the end, what you get out of it is a fairly resilient architecture, and then it's built from the application all the way down.
So, Zach, that actually brings to mind a couple different ideas. First of all, I'll give you one that's slightly colorful, which is, as you may know from reading my bio, I'm an adventure kayaker. One of the things they teach you as a kayaker, most people get into a kayak and say, I never, ever, ever want to capsize. That's like the end of the world. If I capsize, the boat goes over and I go into the water. As a kayaker, the first thing you learn is how to capsize and roll or self-rescue. And when you said, we wipe out the environment every month just to make sure we can do it, I thought of all the endless rolling drills, like at the beginning and the end of every expedition. You roll and, you don't like it, but you have to make sure that you keep yourself fresh. So I thought of that. But the second thing I thought that was really fun is that idea that essentially you forced everything to go through GitOps. And I think you were the one that mentioned the whole notion of infrastructure as code, and the people that have a particularly difficult time with that are often the network guys. And I'm wondering if network folks could get into the practice of just taking the network down every month, and then the configuration the configuration changes should be tracked, so that any changes that got made, if they were made outside the change management process, get wiped away. I bet that would inject a lot of discipline into the network level of the infrastructure, which currently isn't there in most companies.
Yeah, I totally agree. And I think as we start to move into the cloud, some of that is starting to happen, right? So the networking team is starting to learn a lot of the configuration management tools. Either they're using Puppet, Chef, or Ansible, right? We happen to be using Ansible here, and they're all good tools, but then, you have to invest in your people, engineers, and then as they start to become more and more full stack engineers, I think your recovery from incidents starts to become much, much better. So to give you an example, and I'll give a plug to our DBA team, right? They're very, very close to me, because I was a DBA, and and we understand each other really well. They've converted themselves to become Kubernetes administrators and Unix administrators and understanding Linux. So you have a DBA that could have been an Oracle DBA, They understand the network. They're doing Terraform, builds. They're building runbooks. They're building Ansible runbooks. And essentially, what you end up is a full stack engineer that's extremely solid, understands the cloud really well. And if you have an incident, they're essentially SREs. And if you have an incident, you essentially need 1 or 2 people to be able to recover. The minute you have 5, 6, 20 different people, and in some cases, I've been in calls where we have 100 engineers on a call, and you're trying to figure out what's going on, and it can go on for hours and hours, and your recovery is much, it just gets drawn out. So you start to, figure out what went wrong. Well, sometimes I'm sure most of you have been there, you just get that one person, and that's the right person that understands the full stack, and your recovery is much faster. So I think investment in people and the engineers and the capability is extremely important so that you have good visibility into the environment. And then, you try it out. You test, make sure that failures is recoverable and everything is in code.
Okay. And speaking of test, and treating everything as code, Paul, I don't know if you want to comment on the fact that GitOps methods are now moving down the stack into the network and infrastructure and how that's happening.
Yeah, so the whole idea of infrastructure as code is the first part of it. And so Zach talked about Ansible playbooks and Terraform as a mechanism to rebuild the infrastructure. And initially, we saw that in the application stack. GitOps was used just to rebuild the applications. And that was great, but now the whole idea of clusters becoming throwaway. So I need to be able to rebuild the whole infrastructure, including the cluster and the applications that run in it. And what is happening is that things like the cluster API, the ability for you to declaratively say, here's what the clusters look like, here's the networking in those clusters, here's the storage in those clusters, in a declaration in Git, and then use automated tooling to rebuild them or repave them, in a very short period of time, is becoming more and more common. Because now you can apply it at all levels, not only in the cloud, but you can do the same sorts of repaving with VMs in VMware or OpenStack. So you're beginning to see this now, as I said, move down the stack. The things that are difficult in the cloud are really quantifying the risk at the network level. And in some cases, you just say, you know what, it doesn't work, repave it. Because it costs me 10 to 15 minutes to do so.
Right.
Don't bother.
Right. Don't bother. Okay, I want to switch gears a little bit. And Allison, I think in our prep call, you were the first to bring up the concept of a blast radius. Do you want to talk about what goes into a blast radius and how people should think about it so that they can then think about containing it? But really just start with a basic definition and what goes into it and anything that might have changed in the cloud environment.
Yeah. So, I don't know how industry standard that is. We use it frequently internally as we think through the impact of a failure and the ripple effect that has across the environment, or in pick a different language, the sort of cascading aspect of a failure. We've got a lot of seasoned technologists on this call. We've all lived the oh my goodness moment of a failure. That you realize, okay, so I've lost my auth system, but so people can't log in. And the next thing you know, that inability to log in creates all these kinks in the environment that back up your calls across the network into your databases. And before you know it, the thing that happened over here is completely broken something over there that had no direct dependency. And at some point, I think as infrastructure is matured and again, you're looking at kind of a lot of years of distributed systems learning here, we learned what kinds of failures in the environment, beyond the obvious, if there's no network, you can't even start. But rather there's application level components like an authentication system or a core file system capability that would actually ripple through your environment in very unexpected ways because they would just create that kind of backup throughout the rest of the environment. When you go into the cloud, you not only have that, but it's even harder to know what they are. Mm-hmm. And we've touched on this theme a few times. You just really don't know your underlying dependencies And so and you see this in the press, right? I mean, my cloud service provider partners will understand, when we read a big failure in an Active Directory, a Kinesis outage. I mean, applications running at the top of the stack might not even know that the services, they might not have a direct dependency. They depend on a cloud service that depends on something that depends on something. And you get these kind of Achilles heels in any infrastructure, and particularly in a cloud infrastructure. So what do you do, right? All hope is not lost. There's sort of many things. Two I'd call out. One is actually, as much as we can't, as much as we have to take responsibility for what we do, we can rely on and partner with the people who are providing us this infrastructure. Start by following your cloud provider's best practices. They know how you can build an application that can protect itself. And this is where you go to the positive side of cloud. A region in a cloud has multiple availability zones. For many of us, that's more than you even have in your own data centers. Couple that with partner regions or sister regions, paired regions, where things like change management are consciously rolled in a staggered fashion. Well, now you can be really smart around the way you deploy your application, because that change that could have a huge cascading effect in one region should never be applied to the sister region at the same time. And you can deploy an application and your data and make sure that your data is resiliently deployed so that you can recover from that. And a little digression, but one of the really nice features in cloud is there is such a broad feature set you can optimize for your business requirement. So there are services that can be basically tuned for stability, as in write to two regions and I'll take a little latency, or for performance, as in I will cope with eventual consistency and some data loss. I'm optimized for performance if I'm a trading system versus a settlement system. Be really smart about understanding that, and you'll recover from, you'll use your cloud provider's resiliency to recover. The last thing I'll bring up is defensive driving, right? Any infrastructure has a few Achilles heels, and if you know them, you can defend against them. It is frequently authentication, right? Nothing happens if you can't authenticate. But, and this is where operational stability and security come in odds. Security would love you to destroy and recreate credentials every 30 seconds. Nothing would perform. So you reach times to life and length of tokens that you can be smart about bypassing if you go into a crisis from an operational perspective, and maybe relax that security posture, extend the life of tokens, limit the impact of an outage while it's recovering, your applications can continue to run. So you can do some really smart things to minimize risks. My life is about minimizing risk, so I'm not in a disaster.
Yeah, and I really, really liked, I liked everything you said there, but that whole notion of, geographic diversity versus performance, in a sense, the idea that you can make the trade-off and say, listen, this is a really, really, really important application, so we're going to be co-locating it simultaneously hot in two different geographies, which will impact end user performance a little bit. So when you hit the key, it might take a little longer for the, keystroke to register, but that means we never lose anything, versus, all right, this is incredibly important. So we're going to minimize the latency between the user and the app. And that means, guys, we have to suck it up and deal with the possibility of some minimal amount of data loss. I think that's actually a very, that's a conversation that people can make decisions on that very, very quickly if you express it to them that way. Which is a good one. That kind of leads me to a question, and I will sort of randomly pick on you, Paul, because you're, sort of in the middle of my lineup, but I'll go through everyone on this one as a round robin. Does or should the move to cloud cause people to rethink the difference between disaster recovery and business continuance? Or to put it another way, is disaster recovery obsolete now that cloud is in the picture, because of the possibility of constant, maintaining 24/7 constant hot uptime? So,
wow, that's a big one. Okay, so it is merging, because business continuity and disaster recovery, assuming that your data is available and your RPO for your data is okay and your RTO for your data is okay, essentially the cloud allows you to converge them. Because if you think about it, disaster recovery means I'm going to start from scratch and rebuild my infrastructure. Okay? Business continuity says I'm going to switch from one to the other. If your recovery time is long enough to allow you to repave and rebuild from scratch, they converge. But always is the question of data. How accurate is the data? How up to date is it? And how am I keeping it up to date and synced across what could be multiple data centers or multiple regions, right? So as Allison said, as you move the container world into the container world, the applications see a data set and it's opaque what it is to them. And it could be a service of the cloud vendor. It could be a service that you built. It could be a database system that already exists that's running. So the compute side is pretty straightforward, and the application container networking is pretty straightforward. So I can repave those and rebuild them real fast, and GitOps is one mechanism to do that very quickly. But the data has to be available to make it work. And so those services kind of fall back to, even today, the traditional ways that we kept data in sync across multiple data centers. So, you'd have primary, secondary, and you had an RPO you could deal with, or you had, primary, so hot, always in sync. And those are still the traditional things. And when you go talk to your cloud vendor, especially if you're using a cloud native service that vendor provides, make sure you understand what that is when it goes between availability zones and between regions and potentially between physical data centers. Get those numbers, because that is a huge risk. But everything else kind of converged. I can rebuild so quickly now that continuity and recovery are kind of almost the same.
Yeah, and I think that's a really interesting observation, because if you're down to whatever it is, 15 minutes without the data, then if your business continuance specs are loose enough to say that you can handle a 15-minute hiccup, you are continuing your business operations even if you're rebuilding, now of course data being the wild card. Chris, what do you think? Are business continuance and disaster recovery really converging in the cloud era? Should we stop thinking about them as separate disciplines, or what?
I actually have this conversation all the time internally, because I've always had this take that, they're two totally separate things. I think everybody on this panel agrees that business continuity is not the same thing as disaster recovery. And both have different costs to them. Zach talks a lot about cost, but being business continuous is going to have a much higher cost potentially than just having a DR plan, right? A lot of folks just think about disaster recovery, whether it's in the cloud or on-prem, as really their insurance policy. So the last ditch effort, if we can't get everything up and running, we fail it over. The other part to that, I think, that gets lost when I talk to customers is I see disasters every day. They're just varying degrees of a disaster. It's what do you define as a disaster? I think a lot of times when we say DR, most people assume tornado,
Sandy,
hurricane,
or exactly.
what I call burning crater in the ground scenario, right? That the whole data center is gone. But with ransomware on the rise, we're seeing it in my space every day. Every single day, people are having to recover from a disaster. It's a disaster of being infected or a cyberware attack or something like that. So in that sense of the definition of disaster recovery, it's not going away, whether it's in the cloud or whether it's on-prem. And the business continuity part, Paul hit it. It's all about, and so did Allison. If you can architect your applications such that they're spread out not only within availability zones of a region, but then across regions, and then in availability zones within those regions, and you can literally run the application real time with minor hiccups, you're going to be in the best case scenario. But can you afford that? Are you in a business that's, you're not going to be a small business customer, right? That's going to run that kind of infrastructure, but a financial or a legal firm or healthcare, absolutely.
So Zach, I'm going to ask you to comment on this, but before you do, Chris, when you were talking about all kinds of disasters, thought came to my mind. There's a a book called Zorba the Greek, which talks about full catastrophe living. And it comes from a great quote in there where somebody asks him, hey, are you married? And he's like, yes, I'm married. I have the wife and the kids, the full catastrophe. And it's just funny because when you described it, that just made me think of Zorba the Greek and the full catastrophe. And what you're saying is cloud becomes just even more full catastrophe living in the cloud. Welcome to the craziness. It's just a matter of how crazy. So, Zach, any thoughts on DR and BCP converging?
Yeah, I think we're in financial industry, and what do? We play on risk, right? CRISIL does a lot of work on risk analytics. And we do a lot of benchmarking. And then you did benchmarking earlier to talk about how different industries are doing, and it's really how much money do you want to spend based on what your risk tolerance level is, and we're always trying to make those trade-offs, right? And before, when we're in the data center, it was like, okay, I need to go create another data center. Can I have another $500 million, please? We'll go ahead and start to build that out, right? Extremely expensive. And by the way, I need 2 of them because, I want to do this. Now, as the cost starts to come down significantly, because you don't have to really run it, the cloud provider is giving elasticity. What you're really doing is building an architecture, to Alice's point earlier, that bakes in a lot of this stuff as part of it, which means that you don't actually have to spend that much. You have to do maybe 5 or 10% incremental spend. And because things are automated, if it's baked in your architecture, you're really not focusing on BCM because the DR component is already getting baked in. And it's really now you're focused on continuity and what does it mean and how much negotiation do I have with the business to say, can you take that hiccup, to your point, and then bake that into how they're managing the risk overall.
Before I get to Rich on the risk, I want to circle back and say, what are some of the concrete things that you would suggest to bake into the architecture? Just, someone who's designing a cloud architecture today, what should they think about baking in?
Yeah, I think the networking components we spoke about earlier, that's a tricky one. Getting the data across would be the second tricky one. And then I think on the application stack, there is some engineering you can do to be able to do it. Now, of course, I'm not giving a plugin for VMware, but use capability like SRM that have been successful that can help. This is a traditional way of taking something that's built traditionally on a VM, get them across, and then all of that can start to get orchestrated, right? So I think if you have capabilities that you can build now, of course, you can do all of that through Ansible. You can do all of that through Terraform to be able to get all of that orchestration done. But really, that's what you bake into the architecture. Now, if you have a live environment, everybody says, hey, I want a live environment. Tough to do, very tough to do, especially when it comes to data.
Yeah, of course. Data consistency is the bane of data management. So basically, look at networking, look at data transport, and look at applications engineering. So I am going to ask about risk, but Rich, I'm going to ask this in a very specific context that I'll then extend to other folks. From a risk perspective, what are some of the questions, and I think Robert alluded to this earlier, and we're going to get back to it. What are some of the questions that people should be asking their cloud provider as it pertains to risk and risk management?
So building off what everyone else said, the technology world is definitely shifting. And the reason we're able to talk about business continuity and resilience now is because we do have a better handle on our stack, and we're able to bring up resilience and have information that says we can bring this up now, or we can look at the different blast radiuses of situations with our cloud providers in particular and look at that architecture. So going back to look at them, we have to think about these plausible scenarios and the testing that people talked about as well. And the fact that what does happen, as Allison alluded to, sometimes something happens to maybe a single sign-on platform or something that's actually impacting you and not the actual database or the service that you're trying to get to at the end of the day. So people not being able to get into systems, being able to make sure that you have the accessibility to get to that platform, maybe with native credentialing or another way, because you're relying on a system to get to a system, because these things are all so intertwined at the moment. You really need to understand that. And at Fusion, we spend a lot of time on doing plausible scenario testing with our customers, starting with an event and working through how does that go through the chain of command, and learning ourselves with the recovery person, because one of the challenges that being, unfortunately, like all of you, there's lots of incidents. Some of them become crises and disasters, but understanding what our recovery capabilities are to tell leadership. Do I invoke? Because a lot of people, there's a cost involved in evoking, there's a time involved in evoking. So being able to understand really what those ramifications are, and if you've tested and you've got a good partnership with these third parties, you can go to your leadership and say, hey, I can switch over to so-and-so. I can do this with confidence. Like you say, with your rolling out of the kayak, it's like turning back around and being able to make sure that you have the data that says this is that, or knowing that we don't have that visibility. You know, if we invoke a disaster here, we could be opening a whole new can of worms and a situation. So for me, it's not so much the questioning, it's the continued partnership with these vendors to know that we're in this and we're actually going to have to deal with situations. It's not an if, it's a when. These things are happening, as people said, all around. There's incidents happening as we've been on this call, that there's help desks dealing with, outages, and understanding how our partners are going to help us and how long it's going to take them to deal with that, what could be a minor issue, but it could be a crater, it could be that smoking hole, because somewhere stuff is sitting on infrastructure with people managing it. The cloud's not this mysterious place. There's still hardware and information at the back end of that. So
okay. Robert, I sort of stopped you when you were jumping in on this earlier, and I'd like to circle back to it. You started going down a nice laundry list of questions that folks should be asking, design questions that CIOs should be asking cloud providers to help minimize their risk, as Rich talks about, with moving to the cloud, particularly from a business continuance, disaster recovery stand. Can you list for us some of those questions?
Sure. And we had started in on the SLAs when I was talking earlier, so we'll pick right back up there. One thing that I didn't mention earlier is different services and different configurations of that service can have different SLAs in the cloud as well. So when you look at a provider, you need to look specific to service and your configuration of that service, what that SLA and that target might be. And it does make, in an older world, you might be looking at power uptime in a data center or things like that. It does make it more complex when you're dealing with multiple SLAs. So as you get that historical data, you need to make sure that it's accurate to your platform, your design. And then for cloud native applications and third parties that design on clouds, right? We got to look at the regional diversity. Is it 2 failure zones in the same region? Is it multiple regions? Is it multiple cloud providers if it's a third party? And then how does that application heal and fail over? Is it a manual? Is it an automatic? What's the failover criteria and timeline? When we look at the big players in the public cloud space, like what is the level of transparency that they're going to have available for you to understand how their environment works? And a lot of times you can see that, you can understand, you can talk to them. I think as Allison had noted, they have best practices that make you aware of, if you design your application in this way, it's going to work well with our backend. And so you need to understand that as you're designing your application, or if someone's designed it for you, then you know how it works. We've seen multiple times in the last few years an event where the provider is trying to communicate with its end users or its end customers, and they actually have their front end for communicating linked to the service that is down in a way that they actually can't communicate. And so I see Paul laughing over there, but it's absolutely true that even some of the challenges we're up against, we see the big guys stumble on, and it's important to just think that through. And how would you communicate in those use cases? Is there a second channel? Things along that nature. And then I think the last thing I wanted to highlight is when we look at public clouds and we look at delivery of our services to our end users. I think Johna had noted earlier, direct internet type access model now. Now we have bad actors that are holding ransom and attacking people in the public cloud, the private cloud, their own data centers, etc. And their primary goal is to make sure your DR or your BCP does not work, right? So that you have to pay the ransom, or you're more likely to pay that ransom. So as you evaluate a cloud provider, find out, do they have a native technology? Would you have to stack a technology? And how would you protect yourself from those type of attacks?
Okay, so I've got, essentially SLAs for your configuration. Cloud native apps, what is the regional diversity there? How do apps heal and fail over if you're buying software as a service? The level of transparency you can expect from the provider, the level of communication you can expect from the provider, and the last one, which just escaped my mind because I didn't write it down. Robert, can you save me on the thing you just said?
Sure. It's really how do they protect themselves against denial of service attacks or ransomware attacks, be it CryptoLocker, some of the popular ones. And, we've seen in our customer base in the last year a very heavy uptick of actual, volumetric-based denial of service attacks against infrastructure with purely a ransom in mind. And the FBI has noted that that's automated at this point, and they're seeing an uptick as well. So that may be something that's coming to you or your business, unfortunately.
Yep, that is a big thing. And I actually just want to highlight one other thing, which is, and I think Allison mentioned this too with a reference to tapes. It turns out you cannot assume that simply because you backed something up, it is free of ransomware. The ransomware attackers are now using APTs and infecting your stuff and waiting 18 months to set off their little bombs. So one of the things that I would strongly recommend is that you bring your data protection people into the conversation early and often to figure out how you are scanning backed up data to ensure that there are no bombs planted by ransomware providers. And there are vendors that provide this capability. It's worth thinking about, because the problem is it's not a technology issue. The technology is here. The problem is it's two different silos usually think about it. Cybersecurity is over here, assuming that if data is backed up, it's secure, and the data people are assuming that they don't have responsibility for cybersecurity because that's the other guys. So just raising that. Paul, you've been nodding so vigorously throughout this whole what are the questions you should ask that clearly I'm taking that as an opportunity to call on you. What would you ask providers? Or what do you say CIOs should ask providers?
I'm just going to highlight actually two things.
Okay.
One, remember, as Allison said, when you look down at the applications and the services that might be cloud native, you have to assume that those run, as Rich said, on infrastructure somewhere. What is their stance on backup recovery for those services? That is absolutely critical. And as a risk factor for planning, it's something that's out of your hands, right? The question now becomes, do I do it or do I use their service? And what would I have to do that? But the other one is, the classic is, what happens when you can't contact the vendor to get this thing fixed because their systems are under attack as well, right? So when we look at cloud native disaster recovery, one of the reasons that we talk about repaving clusters, the whole thing from scratch, is that if push comes to shove, I can whip out a credit card and go to a totally different cloud provider and rebuild and rehydrate my application if I have to, as the absolute worst case, right? And so that ability to try and make as much of your application stack and the data that it requires opaque to the applications and easily movable is critical. And so I'm laughing. It's like, yeah, I can't get a hold of this particular cloud vendor. His 800 number is swamped. What do I do?
Yeah, and that whole notion of communicating effectively draws into something I was going to try to get into here, but I don't think we have time for it, which is your incident response policy and the need to update it for the cloud era. I actually have a whole presentation on that. If anyone's interested, contact me. I'll send you the link. It's already been presented, so you can watch it at your leisure. But as we sadly are drawing to the close of this fabulous panel, I am now going to inflict my favorite torture on my panelists, which is that each of you has, and since we have, 9 minutes and 1, 2, 3, 4, 5, 6 panelists, okay, everybody is getting 90 seconds. I think that my math is good, to give me the one thing that people watching this should do and should do differently having viewed this. It has to be practical, concrete, actionable, and the only rule is it can't be the person that, it can't be something that has been already said, so it has to be unique. So guess who wins by starting first? Chris, you win. What is the one thing?
It's like winning the white elephant contest at Christmas.
Yeah, what is the one thing? Go.
No, I actually had mine. I'm going to echo what I put at the beginning, because I talk about this a lot, and I think everybody needs to start now re-examining processes that are either documented or undocumented as you're moving to the cloud, because that piece will always get forgotten. And whether it's the applications or anything else everybody's talked about, there's always the people and process that has to be really, really examined. And do you have the right talent? Do you have the right expertise? Do you have the right bodies in place to manage everything, to do the automations that are missing? Can you fill the manual gaps? And I think that's something that people can do today. You just have to walk away and actually start auditing. Auditing is a bad term, but you're all financial people. I'm the one person who's not in the financials here, but you want to audit those processes and really say, well, you know what, this one is 3, 4, 5 years old, and it's just not going to adapt to where we want to go to. So even though you put me first, I had that one and I was hoping nobody else would use it. But
no, and I think that's a great one. And that's exactly what we want. Something people can do today. And that is a recap of something that was already said. Okay, Rich, you are up next. What is the one thing people ought to do? Actionable.
Okay, so Chris took the one. No, just kidding. I think for me, it's tying things back to the important business services. That's where the trend we're seeing in resilience now. It's that prioritization. So the expectations of the regulators and the resilience we're doing is mapping back to these mortgage payments, these loans, these investment vehicles that you're doing, and understanding where you go. So when you transfer to that partner in the cloud, having that partnership understanding of how resilient you have to do you have to go down? So as business continuity professionals for ourselves now, we have incident response capabilities and DR information. If we're housing DR information, we're on a Salesforce cloud. We sit on a very independent cloud because we don't want to be on the production environment. We want to be in an independent cloud. We want to make sure people that need to get to ITDR plans are able to credential in themselves with native identification. We make sure really important stuff is pushed to them on a daily basis, so they have at least some cadence of information that's cached locally, because we're going denial of access to those types of systems when we're working with customers.
And that would be your 90 seconds. Tie things back to the business impact. Thank you. Next up, Robert.
Sure. I think I'll switch gear a little bit here. We talked about a lot of modern things today, and I think one of the things that you should take as a takeaway to this is you need to identify the real requirements of your applications and their failover scenarios. And if you're looking from a lens of not having everything in the modern, cloud-first application written era, that's okay. So pick the real requirements, and if you're going to do a development effort, do it in one thing, and step through your environment.
Okay, so identify the real requirements of your applications and step that through your environment. Excellent. I'm going to do the 12 days of Christmas here. We started with Chris, start re-examining your processes as you move to the cloud, look for talent and expertise gaps, and look for manual areas that can be automated. We have we have Rich with tie things back to the important business impact. We have Robert with identify the real requirements of applications. Zach, you're up next.
Right, so those two are taken.
3.
3 are taken. So let me go somewhere else slightly different. How many of you run your DR tests and they're fully scripted and you prepare for them? So you get all the teams together and say, hey guys, we're going to do this DR test. Let's get all the teams, let's get the mock exercise. And then on the weekend, let's go through this, and then we're successful. Well, DRs don't really happen. They don't announce themselves, they happen, right? So, what do you need to do in order to get the comfort level to be able to execute it when it does happen? Do you have an incident response team that will respond to it? And the key decisions you have to make, you're going to be making them properly. So get your teams trained as part of it. So I think if you're going to be looking at a DR test that is scripted, guess what? That script is going to go out the door. You've done a lot of planning. When it actually happens, and a lot of us have been through it, getting that bridge on with the right people and the decision-making process, that they're solidly on top of it. I've run plenty of recoveries in my time. I think becomes really important. So you could test that when you move to the cloud. What is it going to look like versus where you are today?
So I'm going to boil all that down to conduct realistic DR tests, not scripted ones, with all that you said, summarizing that.
Yeah.
Yeah, which basically, back to the model of doing kayak rolling, is don't set up, sit in front of the wave, and then go. It's like, actually tell your friends to push you over every now and then so that you can really practice rolling and what we call a combat roll. Okay, great. Paul, you're up. Allison, that means you are the caboose, so you'll have to think of something out of that.
So I'm going to keep mine very short. For every system that you build for disaster recovery and for business continuity, specifically more toward business continuity, you set these systems up and you configure them in whatever manner you use, GitOps, infrastructure as code, whatever it is. You want to make sure that you're observing whether they're actually still running. How many people have flipped that Frankenstein switch over to the backup and realized that, hey, wait a minute, that stuff went down 3 weeks ago and we didn't know about it? The same rules apply to primary and secondary, and make sure that whatever tools you're using to build these things are observable at every level, application stack, all the way through the infrastructure and everything else.
Okay, so make sure your tools are observable, both primary, secondary, tertiary, all backup. Excellent. Allison, the one thing people listening to this should do, take it away. Can't have been said before.
Tabletop the impossible. So we did a tabletop exercise called bare metal recovery, which I think probably many have heard of. And we walked in, we took really smart people, really knew everything, put them in a room and said, pretend you showed up and you had a network and you had servers, but all your data was wiped. And after we spent 2 hours convincing them that we knew it was impossible for that to really happen, but you still have to think about it, because you will do that, you will find your Achilles heel. We discovered some really kind of scary stuff that was super easy to fix.
Excellent. So tabletop the impossible, which is not only super actionable, but also really, really catchy. And with that, we are noon exactly. Please observe that we hit it on the nose. Well done, panelists. Thank you very, very much for your insight. And this was a great session. Thank you.